Hi everyone, Sam from DMTI, and in this video we're going to talk about a concept that tends to give students and teachers a lot of difficulty, and that is solving multi-step word problems or multi-operation word problems. The first thing, just to kind of acknowledge that some of the reasons why these types of problems tend to be difficult has to do with the fact that they often have a lot of text, so there's just a lot of information to read through, and that can be troublesome, particularly for students that aren't really strong readers to begin with. Also, there's often times where students get so accustomed to just solving a single operation in a story problem that they tend to think they've solved the problem when they've just done one part of it. Those are definitely issues to take into consideration, but the real serious reason why students struggle with multi-step problems actually has to do with some bad habits they've developed with just single operation, more conventional story problems. And let me give you a quick example, and then we'll apply this an approach we find a lot of success with to a multi-step problem. So a simple story problem that students often have difficulty with is saying that you've read 7 books and you want to read 12, so how many more books do you need to reach your goal of 12? A lot of young students end up saying 19 because they hear a joining additive action, the idea of reading more. They hear the numbers 7 and 12 and they just assume they're going to add them together. However, if instead of thinking about an equation or how to solve the problem first, the first thing they do is draw a diagram that just represents the structure of the problem. Before they've even written an equation or thought about how to calculate, this will help prevent them from that misconception of adding the 7 and 12. So the key idea here when we move to multi-step problems is to actually take each part of the problem and think about it as just a single model to represent what's happening here, and then transition that as you move through the sequence. So let me give you an example. We'll keep the numbers fairly easy. Let's say there's a young girl, her name is Deani, and she's going to make some money in the spring helping weed and take care of some gardens in the neighborhood. And so every garden that she weeds, she gets $5. And on Saturday, she worked on 5 gardens. And then on Sunday, she worked on 3 gardens. And the problem we have to ultimately solve is to figure out how much more money she made on Saturday than Sunday. So again, every garden is $5. She weeded 5 on Saturday and 3 on Sunday. We have to solve how much more money did she make on Saturday. So the first thing we would do is just represent the information that we know before we even worry about solving it. So I'm going to draw just a simple bar model for what she did on Saturday. So that's how much money she earned. Each of those are dollars. So each of those represents a garden, and she earned $5 each time. Now I'm going to do the same thing for Sunday, where she worked on 3 gardens. And so just this situation alone just tells me what's a key idea here, what's happening in the problem. And now in order to find what is this difference here between them, the first thing we're going to do is solve what did she make on each day. Now, there's a ton of tools we could use to figure that out. I kept the numbers fairly easy because I wanted the calculation to be fairly simple. Some kids could just use repeated addition. Some kids could use ratio table. Some kids just know that 5 times 5 is going to be 25. So now I'm going to draw another model that just says that's $25 that she earned on Saturday. Same process here to figure out what she did on Sunday. And that's going to be $15. And now I'm drawing a new model that's a compare model to say, this is now the second part that I'm going to figure out is what's the difference? How much more did she earn on Saturday than Sunday? A couple different ways to solve the problem. You could transition to an equation. My personal favorite is to think adding up from 15 to get to 25, or we could say 25 subtract 15. And we find out that this missing part here, the difference is $10. So that's the way we would approach a multi-step problem. And again, it goes back to what we do with single operations. If you can see it, you can solve it. So model it first and then move on to the next part of the problem and follow that sequence all the way through.